Begin by talking about how to describe categorical or qualitative data. And one way we're going to do this is through what's called a frequency table. And a frequency table is where you you organize into two columns. On the left column, usually you list out the categories, the different ways that you are categorizing your data. And then in the right side is the number of data observations inside that category. So maybe I have 20 people and I find that 7 of them have blue eyes. So I would have a column where on the left I have blue, and on the right next to blue I have 7. And then we just list all the categories with how many values or how many of that category we have, and that is our frequency table. So here's an example of a frequency table. An insurance company determines vehicle insurance premiums based on known risk factors. If a person is considered a higher risk, their premiums will be higher. One potential factor is the color of your car. The insurance company believes that people with some color cars are more likely to get in accidents. To research this, they examine a police report for recent total loss collisions, and the data is summarized in the frequency table below. So here's the frequency table. This is what it looks like. On the left side, we've got our categories, which are all colors. So we label that column as color. So we've got colors of car: blue, green, red, white, black, and gray. And then on the right, we have the frequency. This means the number of blue cars is 25. The number of green cars was 52. The number of red cars was 41. The number of white cars, 36, so on. So this is a quick way to organize qualitative or categorical data just by the frequency of values. Now, from a frequency table, you can create a picture just illustrating the data in the table. And we usually do that with a bar graph. And a bar graph is a graph that displays a bar for each category, and the height or length of each bar indicates the frequency of that category. So here's an example. I'm going to go ahead and sketch it out. So we've got our table. This is just our previous example. These are the colors of cars. And we, on our horizontal axis, we write each of our categories. And so we've got blue, and green, red, white, black, and gray. And then we've got our vertical axis is going to be our frequencies. And so to determine this axis, I usually look at the highest number that I've got and kind of put that near the top. So 52 is up here. So let's see how many ticks I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So maybe I go by 5s, okay, and make this a 55 up here. 50, 5, 10, 15, 20. Okay, so there's our vertical axis, and now we just create a bar for each of these categories. So we're going to go ahead and do our rectangles. So for blue, we're going to create a rectangle, a bar that has a height of 25. So saying blue is this at this tick mark, so I'm going to go ahead and create a rectangle that has a height of 25. Okay. And then for green, we've got 52. So I'll create a bar that has a height of 52. So right around there. Okay, then red is 41. So I will go ahead and draw a vertical bar up at 41. And then white has a height of 36. So I'll go up to just a little bit past 35 there. 36. And then black is 39. So it's not quite at 40. And then gray was 23. Oh, 23. Okay. And then often in graphs like this, if the number itself is kind of important to know, then people will actually write the number above the bar. 25, 52, just so that the data is still there perfectly, and you can't misinterpret the numbers. But the those numbers are not necessary for a bar graph, but they do complete the picture. Now you'll notice that this picture gives a very quick indication of kind of what's going on, okay? Faster than just looking at these numbers. Looking at the numbers, you have to kind of, realize that, 52 is like twice of 25, whereas, here you see the height, and it's a lot easier for our minds to interpret that. One important aspect to know about bar graphs when we're illustrating qualitative or categorical data is that notice that the bars do not touch each other. Okay, and that's going to be important later on when we talk about organizing quantitative data. So for our categorical or qualitative data, we have bars that do not touch each other. A special kind of bar graph is called a Pareto chart. A Pareto chart is just a bar graph where we order our bars from highest to lowest frequency. Okay, and that's just to quickly organize the data so people see the ordering as well. So let's go ahead and take that same example that we did with the colors of cars, and we're going to order these from highest to lowest. So green is first. I'll go ahead and put a 1 there. 52 is the highest, and then 41, and then 39, and then 36, and then 25, and then 23. Okay, and that's how we're going to go. So we'll start with green. Green will be first, and then our red, and then and then black, and then white, then blue, and finally gray. Okay, and we'll again go by fives here. So 5, 10, 20, 30, 40, 50. All right, so now we'll go ahead and do our rectangles. So for green, we go up to 52. So we do a rectangle going up to 52. And then for red, we've got 41. So up to 41. Again, they have to be perfect, but as close as you can get. Black's 39. White is 36. 6. Blue is 25. 5. And then gray is 20. Okay, so there's our Pareto chart. It presents the same information as the previous bar graph or bar chart. However, it has the added bonus of now being ordered. And so someone that cares about the ordering of these can quickly look and see how two colors compare without really having to look at the heights of the bars themselves. Another way of presenting data for qualitative or categorical data is a pie chart. And pie charts are not always appropriate to use for categorical data. They're only appropriate when our data represents a whole, meaning we have all different possible values represented, and then we want to show how the whole is divided into separate parts. So a pie chart is just a circle, and we just have sectors of the circle, wedges, cut that have sizes that represent the frequency and the proportion of data with that value. So let's look at an example. This is the same example as the colors of the cars in the total loss collisions. And so we've got here our graph, and this shows us how of all the cars, this is how they're separated by color. And we see now, the green makes up about a fourth, and black makes up about a third, and so forth. And so this is a nice, useful way to present information if you care specifically about how the data is broken up into different parts. So let's go ahead and try and create a pie graph or pie chart from Zeta. We're going to create a bar graph and a pie chart to illustrate the grades on a history exam that are shown below here. So we've got our categories, which are A, B, C, D, and F, and then the frequencies for each of those. And so it doesn't say to create a frequency table, but I'm going to go ahead and do that as well. So I've got grade, and then frequency. Okay. And so we've got A, B, C, D, and F. And we've got 12 students that got A's, 19 that got B's, 14 that got C's, 4 with D's, and 5 F's. Okay, there's our frequency chart. And we want to create a bar graph. So we create our axes, our vertical axis and horizontal axis. And on these axes, so on the horizontal axis, we're going to have our grades. So we've got A, B, C, D, and F. And then we have heights. And again, we take the highest one, and that's going to be kind of near the top. So 19, so I'm going to go ahead and say 20. 20 is up there, and then we'll go ahead and cut this. That's 10, 15, 5. And then we always want to label our axes, actually. That's best. So this is grade and number of students. Number of students. All right. So with an A, we had 12 students that got an A. So we'll create a bar over A that goes up 12. And then B is 19, so we'll go ahead and create a bar that goes up to 19. And then C, we got 14, so go up 14. And then D, we had 4, and so around there. And then F was 5 up to 5. Okay. You'll notice I haven't actually explicitly stated this. However, it's important to know that when we're doing bar graphs, you want to make sure that the widths of each of your bars is the same. The reason this is because when people are looking at a bar graph, the mind is actually not just interpreting height, it's interpreting the area that it sees. And so we want to make sure that the widths are all the same so that the area seen is proportional to the length or height of the bar. And that's going to help people to make accurate interpretations. Okay, so there's our bar graph. Let's go ahead and create a pie chart. So for a pie chart, we need a circle. And we'll do that right here. Okay, there's our circle. And we need to create some sectors of this. Now, in order to do this, we're going to need to know the proportion that each of these is of the whole. So I need to know, first of all, the total. Okay, so I'm going to go down here and my total, I'm just going to add these up. So 12 plus 19 is 31, plus 14 is 45, plus 4 is 49, plus 5 is 54. So we've got 54 total. And then I'm going to go ahead and find the proportion that each of these is. So I'm going to do 12 out of 54. So 12 divided by 54 is, if I get a decimal, it's 0.2, or the fraction is 2/9. And I don't just care about that. I actually would like to kind of know what the measure of the degrees will be, because I'm creating angles here. And so what I like to do is actually take that number and multiply it by 360, because there's 360 degrees in a full circle. And if I do that, that tells me, okay, this is going to be an 80 degree angle. And so I create that, okay, and I just go straight down and then create an 80 degree angle. Now, you don't have to be perfect with your angles. So, I can say, well, I know that 90 is a right angle like that, and it's 10 less than that, so maybe it's something like that. Okay. So this is A, label there. Okay, and then we do the same thing for B. So I need to take 19 and say 19 out of 54. Okay, that's the proportion. But I'm going to take that and multiply it by the 360. And I want to make sure that I've got a number that's meaningful to me. So I'll get my decimal there, 126.67. And so I need to create a 120 degree angle. And now I'm going from this line here. And so I'm going to go ahead and say, well, straight across would be 180, but it's not quite that. It's just 120, which is 60 degrees less. I know, of course, that that's a 90 degree angle about right there. 30 degrees more than that, so you just kind of estimate. Looks like maybe around there. And that would be my B portion. Okay, and then for C, we do the same thing. We take our 14 out of the 54, and then we're going to multiply that by the 360, and I want to make sure I get a decimal out of that. So let's do that again. My calculator misinterpreted what I was doing. So it was 7 out of 27, and then multiplied by 360. Okay, so about 93 degrees. So that's very close to 90 degrees. We'll go ahead and create what looks like a 90 degree angle, and it's just a tiny bit more than that. So it looks like that's probably good. And that is C. And then our next portion is D, and that's 4 out of 54. So I take my 4 out of 54 and go and multiply that by my 360, and I get about 26 degrees. And I'm going to at the same time do my 5 out of 54 for my F's times the 360, and that's about 33 degrees. So I'm going to go ahead and create this. It creates both of those, and it's not, we know that there's slightly more F's, so we're going to just kind of go over like that. It's going to give us a good approximation there. So D and F. And of course, if you wanted, you could do this by color, and we could have shaded each of these in by color and then had a legend on the side that tells us what each color represented. But it's also perfectly fine to just label those sectors right in the survey.